Hi everyone, I'm Chris. I'm an iOS engineer at Instagram, and this is the story of the time that I tried out HEVC for video uploads. For some context, we run a variety of different products at Instagram, or surfaces as we call them. We have IGTV, Feed, Stories, and Direct, and they all run at different bit rates because we've made different trade-offs with them. For some surfaces, particularly Direct, our messaging platform, our bit rates tend to be fairly conservative because our creators are very sensitive about latency. But that's why HEVC was interesting to us. With the thought of up to 40% better compression than H.264, we could see this going one of two ways. Either higher quality using the same bit rates that we use for 264, or maybe the same quality at even a lower bit rate, giving us a latency win. So of course, I went to go try it out. I took some videos such as this one, encoded them using H.264, HEVC, and because it's supposed to be more efficient, HEVC at 75% of the bit rate, 50%, and even 25%. Your eyes do not deceive you, these all look nearly identical. So with that in mind, we shipped it. That's false, we did not ship it. At Instagram, before we ship anything, we first run an experiment. So we run our code on a small proportion of users to see how it does under real-world conditions, and we start with our own employees. This is the test setup we used. Here's our control group, H.264, HEVC at the same bit rate as 264, then 75%, and then 50%. Immediately after starting our experiment, we got some feedback from some DOCFOODERs regarding their stories. These DOCFOODERs were in the 50% group. Here's some of what they said. The small text is so blurry that it's basically unreadable. The low video quality is really a bummer. The drop in quality is honestly embarrassing. How is this possible? I tested myself. Well, let me give you an example of what they were seeing. Here's an example video. I'd like you to look at the geotag in the lower right-hand corner, and you can see as I continue to play the video, the tag becomes more and more and more unreadable until you can actually not tell that it's text anymore. So clearly, the 50% group is out at this point. These creators have much more complex videos than what I tested with locally. What's going on with that geotag, though? In order to find out, we employed a tool called Stream Analyzer, and here's what we saw. Stream Analyzer shows us every frame in the video, what type it is, I, P, or B, and also how many bits each frame in the stream takes up. So what you can see from here is that the first frame in the stream takes up a completely disproportionate amount of bits compared to the rest. This seems not ideal, so we filed a radar. Meanwhile, we went to go look for a workaround. As you may know, there's two ways of setting target bitrate on iOS. There's the average bitrate key that we usually use, and another key called the data rate limits key. So we gave that a try, and StreamEye to the rescue again. Here you can see on the right side, using the data rate limits key, the first frame is actually 80% smaller than it is using the average bitrate key. That's pretty cool. However, a keen eye will also notice that there's only two types of frames here now, rather than three. That's right, when you use data rate limits, you don't get B frames. We asked Apple about this, and they confirmed what we were seeing. Number one, using the average bitrate setting, the encoder sets to capture rate control, which sets up a poster frame. Overcoding should be mitigated soon. It's a known issue. Regarding B frames, we don't support them at the moment. We should feel free to file a bug report should we want support. Don't mind if I do. Meanwhile, what matters more, having a proportionately sized keyframe or having B frames? We went to go find out. Back to prod to test again, this time employing a new mechanism that we introduced to measure SSIM. This is really cool because now we don't have to rely on user feedback anymore to see how lossy our encoding is. Here's our setup. H.264 using the average bitrate key as we usually do. HEVC also using average bitrate at 100% of the bitrate that we use for 264. Same group but using the data rate limits key, and then two more groups at 75% of the bitrate. So before I show you the results, I want to show you our hypothesis, because every good experiment should have a hypothesis. This is what I expected. I expected at 75% of the bitrate that we use for H.264, I would get at least the same SSIM out of HEVC. And then if I use the same bitrate that we use for H.264, we should get a higher SSIM. Here's what we saw. Well, using the average bitrate key, actually we get lower SSIMs, regardless of whether we use 75 or 100% of the bitrate. How about the data rate limit setting? Well, in fact, it's even lower than average bitrate. So it turns out B frames do matter. What's going on, though? How come we're not doing better than H.264? In order to figure out if our experiment was legitimate, we went back to some local testing to do some analysis. I encoded a variety of videos at a range of bit rates and then measured their SSIM. I used H.264, HEVC with the average bitrate key, and HEVC using the data rate limits key. For reference, this is 75% of our story's bitrate that we were testing with. And indeed, you can see that H.264 has a higher SSIM than HEVC. How about 100% of the bitrate? Still, H.264 has a higher SSIM. It looks like we'd actually have to increase our bitrate about 13% before we start getting wins from HEVC. This seems not ideal, so we asked Apple about it. Here's what they said. They had a couple thoughts for us. We can investigate some more into that. Could you please run it through some more sequences to see if you see the same results? Why is that? The one attached is a heavy snow scene, which the HEVC encoder may not be optimized for. You got me, Apple. I sent you the snow scene. However, the data we got out of the snow scene is consistent with the results we saw on a million other videos in production, so this is on par with the levels of complexity that we deal with on a daily basis. Also, could you please provide PSNR? Okay, I can do that. So, same range of bit rates again, same codecs, H.264, HEVC with average bit rate, and HEVC with data rate limits, but this time measuring PSNR. Here's our reference again, 75% and 100% of our regular bit rate, and you can actually see now that using PSNR, HEVC with average bit rate or data rate limits both score higher than H.264. That's pretty cool. It turns out actually, according to this, we could lower our bit rates about 15% to get wins out of HEVC. Is this how Apple measures better quality or better compression? Maybe, but the 15% win was not the 40% win that we hoped for, so we held on for a bit to see what else Apple had in store for us. July 2019 came, and with the new July comes a new iOS, and with the new iOS comes updates. Apple had two for us. One, iOS 13 resolves the excessively large first frame, and two, iOS 13 now supports B-frames with data rate limits. So of course, I had to give it a try. Here's our setup again, a little more simple this time. Just H.264 in the control group, plus two test groups, HEVC, one using average bitrate key, and one using the data rate limits key. So same bit rates all around, just two ways of setting them. As a reminder, here's how we did on iOS 12. You can see HEVC using the average bitrate key had a slightly lower SSIM than H.264, and then using the data rate limits key, we trailed farther behind that. How about iOS 13? Well, in fact, using the average bitrate key, we still saw a lower SSIM than H.264. What about data rate limits? The gap actually widened even more. That's pretty interesting. So the fact still remains, we cannot see the same SSIM at our story's bitrate using H.264, or using HEVC, sorry. There is good news, though. What if we look at some absolute numbers between iOS 12 and 13? Here's how we did on iOS 12. Again, you can see H.264 in the lead, followed by HEVC with average bitrate, followed by HEVC with data rate limits. When we look at iOS 13 numbers, we can actually see that everything improved globally, which is pretty cool. Even H.264 improved, and it just turns out that using the average bitrate key improved more than the data rate limits key. So check this out. Using H.264 with HEVC, or using H.264 with average bitrate actually has a similar SSIM on iOS 12 to using HEVC with data rate limits on iOS 13. So that's pretty cool. My story ends here for now, but I have a couple conclusions to make. One, the iOS HEVC implementation might be optimized for higher bit rates than we use for stories. However, there's still potential for us to utilize it for lower bit rate surfaces. Why? We're also seeing that encoding is slightly faster, and file sizes are slightly smaller. So there's potential for us to increase the bit rates a bit, maybe still have a latency win, but the same SSIM as H.264. On top of that, there are possibly many ways to define better compression. It could be that encoding is faster, file sizes are smaller, it could be higher SSIM or PSNR, or it could be something else. Regardless of the case, We do appreciate Apple for working with us through this, so thank you, Apple, and thank you.